Okay, let's take a look at this systems of equations problem. A man flies a small airplane from Fargo to Bismarck, North Dakota, a distance of 180 miles. Because he's flying into a headwind, the trip takes 2 hours. On the way back, the wind is still blowing at the same speed. So the return trip takes only 1 hour 12 minutes. What is his speed in still air and how fast is the wind blowing? Okay. So first of all, we want to start thinking about our equation that distance equals rate multiplied by the time. Okay, so in this problem, it tells us that our distance is going to be 180 miles. And we actually have two trips happening. So we have one that is going from Fargo to Bismarck, so I'm going to write F to B, and then one that is returning from Bismarck back to Fargo. Both of them are 180 miles. Now, it tells us that going from Fargo to Bismarck that they're flying into a headwind, meaning that it's going to be slowing the plane down. So let's say that X is our plane speed and Y is the wind speed. So on the way there, our rate is actually going to be the plane speed minus the wind speed, because that wind speed is playing against our plane speed. So if you want to think about it as, let's pretend the plane is going 100 miles per hour, that wind is counteracting some of that speed, so it's causing it to slow down. That's why we would have 100 minus whatever, let's say it was 30 miles an hour, then the plane's really only going 70 miles an hour, if that makes sense. And then the time it says for Fargo to Bismarck is 2 hours. Now here's where it gets a little bit tricky. It says that it's 2 hours going there, but then from Bismarck back to Fargo is only 1 hour and 12 minutes. You can choose to do this one of two ways. You can choose to translate them both into minutes or translate them both into hours. What you can't do, obviously, is to keep the 1 hour 12 minutes the same. So in this case, I'm going to turn them both into minutes and show you how to do it that way. So this top one is going to be 2 hours, which I'm going to convert to 60 times 2, 120 minutes. And then the bottom one is going to be X plus Y. So now he's traveling with the wind. So if you want to think about it, the wind is giving him a boost. So the plane plus the wind speed, and that is going to be only 1 hour and 12 minutes, which translates to 72 minutes. Okay, now I have two equations. Next thing I'm going to do is to rearrange them and kind of multiply them out. So I'm going to use my distributive property on both of these. So I get 180 equals 120x minus 120y. And then 180 equals 72x plus 72y. Now I'm going to use the method of elimination in order to get rid of these. So I know that 72 times 5 is going to give me 360, and then 120 can also be multiplied times 3 to get 360. So I'm going to cancel my y's here. So I'm going to multiply this equation by 5 and that whole equation by 3. So 5 times 180 is 900. 5 times 72x is going to give me 360x plus 360y. Then my top equation here, 180 times 3 is going to give me 540 equals 360x minus 360y. And now I'm just going to combine these so I know that my y's cancel. And 540 plus 90 is 1,440 equals 720x. Divide by 720, divide by 720, and I get 2 equals x. Now you might be thinking, 2 equals x, like, okay, so you said x is the plane speed, so that's 2 miles per hour. Well, this is actually 2 miles per minute, if you want to think of it that way. So in order to convert this 2 miles per 1 minute, if we want to convert this to hours, we need to change it. So I know that there are 60 minutes in 1 hour, which gives me 120. So my plane is really going 120 miles per hour. Now we need to figure out what the wind speed is. So go back to this for a minute. I have x equals 2. I'm going to plug it back into one of my 2 equations to solve for y. So I'm going to plug it into this bottom equation here. So 180 equals 72 times 2 plus 72y. 180 equals 144 plus 72y. Subtract 144, subtract 144. So now that I've subtracted 144 from both sides, I get 36 equals 72y. Solving for y, so divide by 72, divide by 72. Well, 36 over 72 is 0.5 equals y. Now again, I have to translate this back into, this is miles per minute, so I've got to go back into miles per hour. So I'm going to do the same thing, multiply it times 60. And if you do 0.5 times 60, you're going to get 30 miles per hour. So how fast is the plane going? The plane is going 120 miles per hour when it is in still air, so no wind, and the wind speed is 30 miles per hour.